Okay, so here we go. I'm going to present this. So let me just start my timer. Okay, so I decided to do my my presentation on the magnetoencephalography, so the MEG for short. And yeah, so basically an MEG is an imaging technique that identifies brain activity and measures small magnetic fields produced in the brain. It's non-invasive and it detects and records the magnetic field associated with electrical activity in the brain. Cool image. So it's a functional neuroimaging technique similar to the fMRI and the PET scan, as well as the Psych test. But unlike those tests, it uses very sensitive magnetometers. So here are a few images of, we've got the MEG in the top three and EEG, which is similar to the MEG, and then we've got the fMRI in the far right. So the signals were first measured in 1968 by physicist David Cohen, so it's still a relatively new test. This photo basically is showing somebody getting a MEG test. It's non-invasive, and this patient is performing a cognitive task with the remote in his right hand and a computer screen in front of him. So MEG accurately pinpoints sources in primary, auditory, somatosensory, and motor areas. It's also used most commonly for locating the onset of a seizure in epileptic patients. And then with this information, doctors are able to determine whether or not the patient is a good candidate for surgical removal. Here's an image of an MSI. We'll talk about it in a couple minutes, but it's an MSI is a magnetic source image, which is the combination of anatomic images, usually an MRI with the MEG. So, like I said, co-registered with anatomic images, and basically what you get is a reconstructed three-dimensional map, which shows areas of activity within the brain. Another cool image, take a look at this if you have time. So there have been not a lot of findings that related to consciousness, because my specific interest in this presentation was trying to determine whether or not consciousness was, I don't know, studied or helped with the benefit of the MEG test. But I think as time permits, we will see more and more. Another cool photo, obviously we aren't seeing the sensors when we look at an image of the MEG, but look at this if you have time. I looked at a study on olfaction, which is like the sense of smell, and it determined that no conscious olfaction was reported. What I did find was that odor-related brain activity, the MAG data did reveal odor-related brain activity, but what was also found, which was kind of unfortunate, at least for me, was that consciousness is not essential for the olfactory stimuli to be processed. Anyways, moving on, you can look at this later if you need. We discussed this, but it's a spatial distribution of the magnetic field. There's an analysis to localize the source of activity within the brain, and then we've got superimposed images with the anatomical images to provide information in both structure and function of the brain. So the major difference between the fMRI, the PET scan, and the Psych test is that they all are dependent on something. The fMRI is dependent on changes in oxygens, PET scan is dependent on changes in glucose uptake, and Psych is dependent on changes in blood flow to parts of the brain. MEG conversely measures neuronal activity just directly. So we've got an image of an fMRI. It's obviously revealing a great deal of information, just not as much as an MSI. So MEG tells us a lot. It tells us about thought, speech, movement, sensation, and most specifically and today it focuses on epileptic patients and trying to help them with their condition. We talked about what an fMRI is. So the PET and fMRI measure changes in metabolism and blood flow over many seconds, while the MEG actually measures electrical activity millisecond by millisecond. So it's more accurate, it's better with time, and its spatio and temporal resolution is much better also. So it's great. So here is an MSI. So basically we've got MRI images, we've got the MEG images, and we've got recordings, and it's basically just giving doctors and radiologists a really good idea of what's going on in the brain. So some benefits is the openness of the MEG setup, the ability to potentially in the future, and even now a little bit, there's some movement allowed. And then, yeah. So psychologists are using this to better understand relationships between brain function and behavior. It also is used to study cognitive processes such as vision, audition, and language processing in fetuses and newborns. So I want to just point out before I wrap up, MEG is non-invasive, it's painless, and it's safe for all ages. There are no injections, there's no radioactivity, and there are no strong magnetic fields. It's the newest, most advanced method, and it's used to map language areas, vision centers, motor and sensory areas, and it's also used to evaluate brain spontaneous activity. So here's another photo. We discussed the benefits. One other photo, this is a pretty, I think this is my favorite one. It's really showing what's going on. And then here's my works cited. So that will be all.